Well, hello. I'm going to go ahead and get started with today's live stream of building a running kind of game inside of Minecraft Bedrock Edition. And so today what we're going to go do is cover, a lot of TypeScript. So I think today's use case will probably be a lot of, coding in TypeScript, building fun things with that and seeing if we can implement various facets of the gameplay that are needed for that. So depending on whether you really like a lot of TypeScript or not, come vibe code with me or just code with me as we work to go create something together. We're not going to be vibe coding. We're just going to be watching myself try to struggle with some of the coding and the kinds of things that are going on there. I'm Mike Emerlon. I'm a product manager on the Minecraft creator team. So I work on the documentation. I work on a lot of the different APIs and experiences that you see inside of Minecraft. And just a very quick disclaimer, you'll probably see some things today, like, if you have questions, feel free to answer them. I can see the chat in front of me as we're going. Where possible, I'll try to answer questions. I might encounter some bugs. I might encounter some things that I'll probably find confusing. So please bear with me. We're just trying to, work through it and hopefully build some fun things on top of Minecraft as we go about it. So let's go ahead and get started and dig into today's topic, which, as I said earlier, was building a running game on top of Minecraft Bedrock Edition. I'm going to try to do this in an hour or less. So based on that, I don't have a ton of time and I got to go ahead and get started. So what we're going to do is we're going to do a lot of coding today, as I mentioned. And to get started with this project, probably the first thing we're going to do is use Minecraft Creator Tools to go get our project started. So for that, what I'm going to do is come to mctools.dev. And one of the things that this is good for, oh, wrong folder, is it has a number of different project starters here to go start, custom Minecraft Bedrock projects. And in this case, we're going to call this runner like that. And I'm going to say use device storage, which means basically store it on my hard drive. And I'm going to go create a folder under C:/projects called runner like this and select that. And yes, I will let it place files on my hard drive and then I'll click OK. And so what this is going to do is it's going to go create that folder. So if I go to runner like this, you can see that there's a number of different starter files here that we're going to use and we're going to spend our time coding with today. So we probably won't be using MC Tools beyond this, but I'm just going to go ahead and open up Visual Studio Code to do a lot of our script editing today. Go bring this over like so. And then I'm going to run npm I, and what this will do is it'll install the various dependencies that this project needs in order to run and to be able to push things to Minecraft. So this is the Minecraft core build tasks workflow. And the idea behind this is as you make edits, as you make customizations, you're probably going to be doing a lot of editing in TypeScript, and TypeScript needs to be compiled before it can be processed by Minecraft. It needs to be compiled from TypeScript into JavaScript, and then Minecraft can understand it. So the whole purpose of this workflow that we've just installed via the npm I command is that it will do all of that work for us. So all good times from that. We've got our basic workflow going. Let's just go get started. I always write this goofy loop, and it's not the world's best loop, but it's my loop, and I'm sticking to it. Let's say current tick equals 0, and then we're going to increment current tick like this, like so. And if current tick is equal to 60 like this, about 30 seconds, or 3 seconds, excuse me, into the Minecraft load, then we're going to call our initialization code. The question, what time is it in the US right now? Well, I'm in the Pacific time zone on the West Coast of the United States. So it is, I'm looking at the clock, it's 2:05 p.m. Or yeah, 2:05 p.m. Yeah, all right. So we're going to call a function called init. Let me actually go and add that function init like so. And let's go call init. And we are going to go say world.send message, hello there. This is a running game. All right, cool. Just like that. And then what I'm going to come back and do is I'm going to call npm run local deploy like this. And I'm going to use this -- and -- watch set of flags. And what this will do is it'll make it so that every time I make changes inside of Minecraft, it'll go push those changes into Minecraft. Basically, it'll copy them over to the Minecraft folder. So I'm going to go get started with Minecraft. This is 1.21.80. It's a standard common build. It's not preview. And we are going to create a new world called, probably appropriately, I'm going to go call this runner like this. And yeah, let's see, creative. Yeah, let's do this creative. I'm going to allow cheats because I like cheating. No, because that's usually good when you're debugging your world. I'm going to make it a flat world because that's also good when you're debugging your world. I think the other thing I want to do, where is it? Let's see. Oh, show coordinates. I always like having coordinates on. It's a good thing as well. Should we start the project with an experiment or will it stay in the stable version? It was a question. I think, usually when you're, if you want to create packs that you want to share with your friends, sometimes it can be good not to do an experimental because your friends probably aren't running experimental, and setting up for a set of add-ons with experimental features can sometimes be a little bit of a hassle. So it's not a bad idea to set up with experimental, um, but if everything that you need to work with is in the stable version, then by all means choose this. Don't work with the experimental. So I'm keeping it simple here. You can see that this runner behavior pack and resource pack, we created them through mctools.dev, we saved them to our hard drive, and then we push them into Minecraft. And so now this is all available for us to go ahead and use like this. And it's going to say a bunch of things about, hey, are you sure you want cheats? Yeah, I want cheats. So we're going to go do that. And here we go. And you can see that our message, hello, this is a running game, has popped up. And we are here in our flat world and all is good times. Okay, so step one is for us to go ahead and get all of our data structures kind of in place. So this is going to be probably the boring part of it. So when I was thinking about this a little bit, I did a little bit of kind of pre-coding of this just to kind of get the concept straight in my mind. So apologies for that. I know everyone likes the danger of me just doing it off the cuff, but okay, let's do the first thing, which is export interface segment like this, like that. Okay, so when you think about a rudder game, there's these stretches that you're running along. So think of, maybe some of the older school games like Temple Run. I know my kids played a lot of Minion Rush, those kinds of things where you're basically running straight forward at a fast speed. And there's kind of like, maybe like there's two tracks side by side. And you're running and you're avoiding obstacles and maybe you're collecting coins and all that kind of fun stuff. And so that's what we're going to do. And when you think about that kind of a thing, usually there's a bunch of just different segments that make up the track of the thing that we're working for. So what I'm going to do is I'm going to have this concept of a segment. So I'm going to set up my data structure for that. I'm going to say the start pause is a vector 3 like this, and my end pause is a vector 3. So we need a point in the Minecraft world where this is going to start and where this is going to end. So in this case, let's say vector 3. I'm going to add that to the imports. And I'm probably going to create like this big interface for game state like this. Oop, I always do that wrong. And so basically my game state will start as basically just a whole bunch of segments. So we're going to create an array of segments like this. And let's see, what we're going to want to do is go ahead and basically when you initialize the first time, well, the first thing we're going to want to do is load and save our game state because we don't want to rebuild these segments every time you join the world. We want to only do it when it's needed. So what I'm going to do is I am going to say world.getDynamic properties. Dynamic properties are this basic way for you as a creator to store data on top of Minecraft. So what I'm going to do is I'm going to look for a dynamic property called, let's make this up, runner state like that. Const result equals state. And I'm going to say if this is a string, then what we're going to do is we are going to try to parse that const result state. Oh wait, we'll just have a variable up here called export. No, we'll have a like var game state, which can be of type game state or undefined equals to undefined like this. And basically what we're going to do is say set the game state to JSON.parse result like this. Result. That was, of all the misspellings of result, that was not a bad one. And we're going to go parse it. So this is basically loading the game state. And then I'm going to implement a function called save state like this. And you can find all kinds of frameworks for doing this in a much more sophisticated way. But what I'm going to do is say json.stringify our game state, let game state stir equals right this, and I'm just going to say world.set dynamic property game state stir like that. So that's kind of cool. And yeah, so that's pretty straightforward, like so. And cool. Okay, so this is basically our save state function and our loading state function like this. So basically, as we build segments, we'll be saving it out into the world and going from there. Okay, so world.savestate, world.loadstate. Let's see. All right, so we're not calling that yet. So the first thing we're going to want to do when we first start the world is we want to say if gamestate.segments.length. Okay, if our game state is undefined, if it hasn't been set up yet, then let's go ahead and define that as segments like so, like this. So that sets up our game state like so. So now it's going, let's see. So yeah, just looking through the questions. If you're the Bedrock content manager, I'm not a Bedrock content manager, so I probably can't speak to any of that. All right, so we're gonna go set up the new game state like this with a bunch of segments. Okay, so now we've got our game state all initialized and it saves as a dynamic property called runner state. Oh, I did that code wrong. So I need to say set the runner :state like so to game state string. Okay. All right, so the next thing we want to do is we're going to want to say, okay, if there isn't an initial segment, if the segments.length is less than or equal to 0, then we need to go build our first segment. So basically, let's see. So we can go say, okay, add segment giving a starter pause like this, which will be a vector 3. So we want to build our first segment. And basically what I want to do is I want to build the first segment of our track. We're going to do our first segment of a track basically near where the player spawns. So to do that, we're going to say var spawn point, or say let spawn point equals world.get spawn default spawn location like this. And this will return a vector 3. And what we can do from here is we will go say add segment like this, and we'll say x starter the spawn position.x and the y spawn position.y and the z spawn position.z like this. And so basically what this says is go ahead and go build a segment using these coordinates. And what we're going to do is say let's see, let's go say let n pause is equal to x with start pause dot x, y start pause dot y, and then we'll just increment the z. How long should each segment of track be? I'm going to make up a number because that's always the fun thing of coding, is making up numbers and seeing what works. All right, so now we've created our first segment that basically starts at the spawn location. Actually, let's go ahead and do it 10 blocks above the spawn location like this. And let's see, how's things looking? Yeah, so then we're going to set the end position. And what we're going to do is say world.fill world. Oh, wait, let's say let's overworld equals world.get dimension. We're going to only deal with the overworld basically from here. So we're going to use some APIs like this. If you wanted to do this in the Nether, that would be a good option. But for now, we'll keep it simple. And what we're going to do is we are going to fill blocks, new block volume like this. So what we want to do is we want to go create the path. And let's see, I'll take any suggestions for the kinds of blocks that we should use for the path. Otherwise, I'm going to go with cobblestone. But let's see, x is, x will be start pause.x -1, and then y will be start pause.y, and z will be start pause.z like this. And let's go. Oh, sorry. I need more curly braces. So the block volume takes a starting position and an ending position in order to do the filling. So we're going to pass in 2 of those, and we're going to say end pause like this, and ends like so. Yeah, so, okay, so this is the start pause and the end pause. So the question came in, what are you making, Mike? I'm making a running game. So basically, if you think about games like Temple Run or other games where you're kind of running along a track and you're maybe moving different directions, it's kind of in that style. Let's say, okay, so we're gonna go fill blocks for our first segment of track like this. And what we're gonna do for the block type, if anyone has suggested a block type, let's go ahead, and if you have suggestions for block type, I'm all ears, but for now, I'm going to do the boring cobblestone. And this will be our first track like this. Now, there's one problem in here that I discovered when I was playing with this a little bit beforehand was spawn location always has this funny thing where the Y is basically like 32,000 or something like that. And the reason for that is that, like, I don't know, I guess that's its way of saying put it wherever on the top of the world. And let's say, okay, right. So what I'm going to be doing here is instead of like let y equals sp.y like this for const player of players, what we're going to do is we're going to fix up the y. Resin blocks. That might be a little bit problematic. All right, so we're going to say world.get players like this. And what we're going to do is we are going to say y equals math.min of y and the player.location.y. So basically what we're going to do is we're going to set up this track not using the spawn location y, because as I mentioned, it's a little bit messed up. It's got like this really high value. What we're going to do is we're going to set the lowest location of any player that's currently in the world at this time. Okay, so that was a lot of data structure coding and getting our stuff all set up. Oh, and one last thing I should do is I should just say this.save state like this. Oop. Anytime we add a segment, we should probably remember to save it. I keep saying this. Save state like this. So every time we add a new piece of the track, we should make sure that we save it like this. Let's go try resin anyway. I'm a person of the people. I think that's going to slow things down. We're going to have to switch away from that. But for our first run, we can use resin blocks. I think. All right, let's go ahead. Okay, so I've saved everything. We've added our first segment. We've dynamically generated it like so. So let's come back into Minecraft like this. I'm going to exit out. I could have just run /reload. I don't know why I exited and reloaded. All right. Okay. Oh, yeah, requested fill volume height was out. See, that's that high value. Oh, see. Oh, add segment. See, I set up the Y, but I didn't actually pass it in. I passed in the spawn point Y, and you saw the error here. If I go to the error list, you can see that it comes in with the spawn position comes in the coordinate of like 32,000, which is a lot. So that doesn't work very well. Okay, so now hopefully, oh, there we go. There's our little resin track segment thing. Okay, like this. And yeah, we can move along on this little track segment like this. And okay. All right, so that's a start. We got a little start. What I'm going to do is when this initializes, I'm going to, so we have this code here, which basically just says set up a segment if one doesn't exist. And the next thing we're going to do is we are going to initialize all of the players. So we're going to say for const player of world dot get players like this. And we are going to position them. So we're going to say player dot teleport to let's see, x and gs.segments. Okay, let's say const starting coordinate equals gs.segments of 0 dot start pause, like that. I'll put this up here, and we're just going to teleport all the players to the starting coordinate like this. So now all the players are in a good shape. The other interesting thing I'm going to do, let's see, remember to leave your, oh yeah, nice. Thanks for that, Kyogre. Yeah, so let's see. We are going to teleport starting coordinate. Okay, the other thing we want to do is we want to constrict the player. So the whole idea behind the running game is that the player is kind of forced to move in a direction, generally just straight forward, and they can like navigate on the track a little bit, but they can't really do too much otherwise. So what we're going to do is we are going to restrict the player. And to do that, we are going to use player.input permissions. And with input permissions, what you can do on a player-by-player basis is actually deny their ability to kind of use inputs to change how they work. So I'm going to say set permission category, and then we're going to say input permission category.camera. We're going to take away the ability to like change the camera a little bit, via the mouse. And I guess you would want to make sure that you test this on consoles and test this on, like mobile devices and stuff like that too. But yeah, so we're going to restrict we're going to set this to false. So we're going to say, no, you can't change the camera. And the other thing I'm going to do is I am going to set the teleport options to rotation. What does this take again? Oh, goodness gracious. This takes a vector 2. So I am going to say x of 0. Well, I'm just going to try to set an x of 0. So we're going to force the rotation to be set for the players. So now the player should be constricted in how they can run. We're setting them on the starting coordinate like this. So let's just go ahead and try this all over again. And I'm going to go reload this guy. And, oop, start pause of undefined. Okay, it did not like this. Oh, okay. Well, that's the problem. Let's see. So I set an end pause. I don't think I actually created the first segment. I did some of the work to create it. So let's do this. Const segment equals start pause of start pause and end pause of end pause. This is my coding style. Cool. All right. So then we're going to say game state.segments.push segment like this. Yeah, that should be fine. Okay. Now we're going to come back in and try this one more time. Now that we're actually saving out the segments as we go. Would it be cool to make a 2x1 spawn randomly throughout the world? Yes. So that's probably, hopefully the next stop is we can go ahead and, so you can't see it, but for one thing, I fell off the edge of my segment, so that's not cool. Player. Oh, I have to make my starting coordinate a little better. Let's see. Then starting coordinate equals starting coordinate x starting coordinate dot x, y starting coordinate dot y, z starting coordinate dot z, like this. Except I'm going to set it to 2, and I'm going to set the y to 1. Okay, so this should do a better job of actually placing the player on the track that we've designed. Okay, like this. Wait, reloading. Okay, so now we're on the track, and now you can see, you can't see this, but I'm actually moving my mouse, like, hopefully it's not dirty. I'm moving my mouse, but it's actually not moving the camera. So the player is now kind of constricted a little bit in terms of how they're running on the track. Of course, I can still run off the edge, which is unfun, but yeah, so that's cool. So in order to stop us from running off the track, we're going to want to set some more blocks onto different track segments like this. So we are going to want to set the block to X, and then we're going to set this to +4, and we're going to use our good friend the barrier block like this, barrier, like so. And, oh, what's this x equals 1? That's a boo-boo. All right, so +1, and then we're going to say x minus 2 like this. So we're creating basically some barrier block walls on the sides of our track so that the player can't actually like run off the edge of it like this. So we're going to say x minus 2, and then we're going to say x plus 2 like this. Why did I add 4 to the, what the heck? Wow, that's confusing. I'm not sure where that +4 came from. That's a little spooky. All right, x minus 2. I think I just missed. +2. Okay. All right, cool. And all right, so this is going to basically place some barriers on both sides of the track so that we can go ahead and do that. Let's see. Okay, so this just to make it a little bit more visually interesting, we're gonna, let's see, what should we do? We'll create some acacia leaves for now, just so that you can see this code in action like this, and just basically for debugging sake. So now the track will be lined with leaves, but in the future, oh, we could replace them with barrier blocks. Oh, okay, let's see. It did not. Oh, because it's reloading the fact that it's saved, so it's not reshaping it. Let's see. Okay, why don't we do this? How about this? Okay, function draw segment, like this. We're gonna split this out into 2 functions, draw segment and add segment, like so. And then we're gonna call draw segment like this. We're gonna pass in the segment. Okay. All right, so now we're drawing the segment, and let's see. All right, now we need to fix this up. All right, sorry. I just wanted to make it so that when the world loads again, it will re-push in all of the segments that are stored, just for fun, like this. The other thing we should do to make this code a little bit more robust, and I can see all my developer friends cringing when I do this, but frequently what will happen, oh wait, actually, hold on a second. There's actually const options, hold on a second, I fill, hold on a second. All right, let's see. Block fill options. Sorry. Block fill options, if I can type. And if we go to this one, there is, yeah, ignore chunk bound errors. So there's this thing where, like, if you try to fill blocks inside of in a chunk that hasn't been loaded yet, then it'll throw an exception unless you set this value, in which case it'll basically just silently fail. And we just want to do that. We just want to silently fail, which, sometimes isn't the preferable thing. Coders hate it to silently fail, but if you're like slightly out of position, or if Minecraft is loading slowly, like, you can get these errors all over the place and you can have a bad time. So I'm going to set the fill block options to ignore chunk bound errors. Okay, and then one last thing, when we load a world, else for const segment of gs.segments, we want to redraw all of our segments like this. Okay, so now we're good. So now it should actually draw the leaves that we've put on both sides of the segment, because we are going to, oh, that's not what I wanted. See, this is why it's good to debug. All right, so, oh, that's why I set y+4. Wow, I really got confused there. All right, so we're going to set y+6. And this is where my developer friends would be like, why are you embedding constants straight in your code? You should have like a constant for wall height and stuff like that, rather than just typing in 6 in 4 separate places. And that's correct. Oh, all right. Wow, that I need to think. See, I'm talking while I'm coding. Okay, so I'm gonna blame y'all for making me talk while I'm coding, because I'm getting confused. All right, so y+6 like this. Okay, let's try this again. All right. I found a bug in event.player game mode change. Where can I report a bug? If you go to just the Mojang bug tracker, which I think is bugs.mojang.com, you can use that tracker to actually report different types of bugs. And sometimes it's not the fastest thing, but they do get routed to the API team where folks can take a look at them. Okay, so what you can see from this is, I can't change the camera. I'm kind of in a tunnel now. It'd be cooler if these were like barrier blocks, because then I could see through the leaves. But now we're kind of in this sort of thing. And so the next thing we want to do is, let's see, what do we want to do? I think what we want to do is we want to have a tick function called, let's say, game loop like this. So this is where we're going to do all our game loop processing and that kind of thing. We want to do that every tick. Else, if current tick is greater than 60, let's go call our game loop function. And our function game loop, like this. What we want to do, so one thing we want to do is if you reach the end of your segment, we want to generate a new segment. We can't generate all our segments in advance because Minecraft won't have the world loaded, which is why you need this kind of staged approach to generating code. So what we're going to do is we're going to say const last segment equals GS. Okay, if not GS, we're in a bad state if we can't load the game state at this point. Uh-oh, no game state. Like this, that's bad. Okay, so we want to say last segment equal game set.segments, gs.segments.length -1. So we want to get the last one. And we want to say let player nearby last equals false. Okay, so then we want to loop over all the players, const player of world.get players like this, get players like so. Okay, and we want to say if, I think there's a better way to do this. What's the better way to do this? Vector utils? Vector 3 utils dot distance. Last segment dot end pause is less than 10. If vector 3 utils dot distance is, let's see, player dot location. So basically, if they're getting to the end of the last segment, and I don't know if 10's the right number here, but I'm just going to go use it. What we want to do is we want to go add a segment. So we want to go add a segment, last segment dot end pause, like this, and cool. And so then we're going to go generate another segment. And what we want to do is, okay, so we're going to generate another segment. And let's see, how do we want to randomize this a little bit, right? So consts ends, let's see, what do we want to do? We want to vary the floor a little bit just for fun. Floor block equals, floor blocks equals Minecraft block types dot resin block, Minecraft block types dot gold block like this, Minecraft block types dot, what's another good block? I'll just do cobblestone just for funsies, like this. And then we want to say floor blocks. We just want to randomly math dot floor of math dot random times 3. So basically what we want to do is each segment should have a randomly picked floor block from one of these 3 types, like so. All right, so now we have the thing where if the player gets near the end of the segment, we should add another segment. Oh yeah, and we'll see what happens. I'm sure there's a bug here. I'm sure there's multiple bugs here, but we'll try this like so. Okay. Okay, oh, gold, okay. Oh yeah, you probably want to, okay, so now, yeah, now you can see it's generating new segments like so. As we kind of roll down it, we're running. And, some fun things are happening like so. And, this is like our little running game like this. You can imagine us starting to like store obstacles or something like that. Now, the fun of a runner game is that, it should, yeah, the chat's definitely saying use constants. I know. Anyway, let's see, what do we want to do? Oh, what do we want to do next? Oh, we want to make the player go fast. I mean, it's not a runner game if you're not running. And the first thing I tried for this, I actually tried a couple things because I wasn't quite sure how I do it. And the first thing I tried was, let's say, player.init. Let's say, and maybe the chat knows why this was happening to me. But if I say player.add effect, Minecraft effect types.haste. Haste is a good one, right? Yeah, haste. Cool. All right, haste. Cool. And I say the duration is 999, like so. And I say, I don't know, I think there's one called amplifier, and the amplifier is 100, like this. Let's just give it an amplifier of 4, right? Okay, so I'm adding an effect called haste to the player, and that should make the player go fast, right? But let's see. Yeah, and you can see that the effect is applying, but I'm not really running fast. And I should know why this is. I mean, I work on Minecraft. I should know, but I don't. Yeah, oh, haste is binding speed. This wasn't quite working for me. I tried something else, which is to do like a JSON override for player.json and change the movement value for players. So the idea there is you take, you put in your manifest, your entities. Speed is what I'm looking for. Oh, speed. Oh, well, okay. That could work. Maybe I'll try that instead. The difference between haste and speed. Good times, everybody. All right, let's try this. All right. Oh, okay, this is faster. Yeah, that works. All right. Yeah, thanks. Thanks, Vapor, for the helpful tip. Speed is what I'm looking for. Okay, so this is fun. I'm not sure why it's randomly choosing to... Oh, I'm almost outrunning the generation. Let's see if I can outrun the generation. Almost. Anyway, so that's a little bit of the idea behind the generation. The other technique that I was going to use, but is actually a little bit more complicated and unfun, is to use like the player.apply knockback APIs, I think it is. You can basically apply nudges to the player in various ways to make them do all kinds of fun things. But this actually gives me the effect I want with speed, so that's good enough. So yeah, so this is just a little bit of the runner. I guess what we want to do is, last thing is we want to probably go create some. Now, the one thing I wanted to do that I probably won't have time for is, make some of the segments go, rather than going like north south, make them go east west in different directions. So it's a little bit of a maze. And you can imagine how you could code that up in terms of like, how when it generates a segment, it can choose a random direction. And so then it can do, different start pauses and end pauses and stuff like that. And then when the player gets to the corner, you'd want to pivot them so that they're facing that rotation. I'm not going to do that here. What I think what I'm going to do instead is just do some very basic, let's do some very basic fun stuff of like, let's go just spawn some mobs every so often. So in our game loop, if current tick is less than modulo 10, so we want to do this every 10 ticks like that. We want to go loop over all the players like this, and we want to spawn behind the if math.random. I like that. This is random. I like that. That should be the title of a game. I'm sure it is. Random. Anyway, well, doom. Anyway, what we're going to do is we're going to say, we're going to go spawn a mob. And let's go do that. I'm going to copy this line of code to go get the overworld. I'm not sure. It would have been way quicker for me to just type that in. And we're going to say overworld.spawn entity and your favorite zombie like this. And player.look, oh wait, const new mob equals world.span, like player.location, like so. And then we're going to say new mob.add effect, Minecraft effect types.speed. Thanks for that helpful tip. Again, can never thank you enough. All right, so then we're going to go spawn some zombies behind the player. This is probably going to do a lot of spawning because it's going to basically spawn 2 mobs every second. I'll make it fun for a little while. All right. All right. Let's see. Oh, there you go. All right. All right. Let's go. Don't seem to be running very fast. They're kind of running fast. I guess I could probably tweak it a little bit to kind of make them. Oh, nice. I like that. I like that there's certain like accidental gaps in the world that. All right. So this is some incentive to keep running for sure. Let's go ahead and let's go do. Wow. Am I sharing the sound? Yes, I think I am. Okay, well, all right. Let's go make the proportion of mobs being spawned a lot less. A little less random. Like so. Oh, yeah. Okay, that's a little harsh. Resume. How about we just come back to creative? That spawns a lot of mobs. All right, let's see. What are we doing? Okay, we want to make this a little fun. So, I mean, I've just been doing it inside of a flat world for now. I think what I want to do is I want to use like a glass block instead, maybe. Glass block. Glass block. Glass? Glass. Oh, not glass block. So inconsistent about whether it's glass or glass block. Okay, so what we want to do is we want to create these tunnels, right? So this is going to be much more fun and it'll look cool when we're in a real overworld and not just a flat world. So we're going to go do this. Okay. So, okay, so now we're going to go basically create these tunnels with glass blocks. And the other thing I need to do is I need to go fill in the air in between them. So let's go try this. So I'm going to fill blocks and y plus 1, 1 and y plus 5, like so. And I'm going to use Minecraft block types.air like this. Okay, all right, so, okay, so now we're gonna go reload this. And so now what we should get is some good glass tunnels. Oh wait, let me go change this. Okay, this is not very wide. Why is this not wide? Oh, there we go. I think it might have. Why is it not wide? Well, it's 3 wide, which is a specified thing. Why are these not redrawing? Oh, I see. I think I see. Oh, I see why these are not redrawing. All right, those aren't going to redraw because the chunks aren't loaded at the time it redraws all the chunks. Okay. All right, let's go create another world. Oh, wait, the other thing we want to do is let's go create this underground. So let's go y minus 10. This will, if y is greater than negative 50, we want this to still work in flat worlds because I think if you subtract 10, it's going to break in flat worlds, but in regular overworlds, infinity worlds, this should create a fun effect, I think. I don't know, we'll see. Runner 2 like this, and we're going to make this survival. And let's go add our behavior pack and our resource pack, although our resource pack doesn't really have anything in it. But let's go create this anyway, and we're going to see what happens. Yeah. Okay, so, oh, cobblestone fell? That's going to make my runner kind of hard, actually. Yeah, that's going to make it hard. Okay, hold on a second. All right, that was an interesting one. Okay, so new thing we have to do is we actually have to, I guess we have, the order in which we do this is interesting. We actually have to fill our roof first so that the cobblestone or the cobblestone. The gravel doesn't spill down like this. Okay, and I guess the other thing we need to do is we should add some torches when we're done, just so that there's some light. Overworld dot set block dot for let I equals 0, I is less than 6, like so. I plus plus. Overworld dot set block type, and we're gonna say x segment dot start pause dot what is it, dot x -1, like this. Okay, I'm doing this kind of coordinate math off my head, but you know, 90% of coding in Minecraft is coordinate math. Start pause dot y plus 3, and then z is equals segment dot start pause dot z plus I times 4, I think. I don't know. This is probably going to create some gaps. Minecraft. I don't know if this is going to work, because don't I have to, like, Minecraft. What's going on? Sorry. Okay, let's try this. Minecraft block types dot lantern. Can I just do a lantern? If I do a torch, I'm worried it might not actually, like. All right, let's try this. Okay. So now we're going to create our tunnels, and we are going to put torches in them so that it's lit. And let's go try this again. See what happens. Oh, cheats aren't any. Come on. All right. Play. Edit. And let's say cheats. We need to cheat a little. We need to reload. Reloading isn't cheating. Come on. Oh. All right. All right. Okay. So yeah. So now we've got our. Hey, we've got our torches on the side like so. And now we can kind of run through this world. You know, this is like Mine Runner, like Super Edition or something like that. It'd be cooler if, I guess if we use barrier blocks, then the walls would be transparent. Rather than, oh, yeah, see, we still have some water spill through. A little bit of a problem. I think if we actually provisioned the side walls too, then, you know, then we'd have some fun. Ooh, this is actually almost kind of challenging in its own way. I'm not sure why the roof didn't get created there to kind of save us from getting flooded. Oh, is the roof not working? Let's see, +6. So, yeah. Anyway, this would fix the bug, I think. Okay, well. Okay, let's try this again. Oh, that was a very cool saving shot. All right. Oh, yeah, I like the idea of making the roof of lava so the player can't stop running. Let's reload this and see if this works. All right, let me go create a new world just to see how this works in this new world. And that's probably about as far as I'll take it today. But you can see how you can do a lot of cool, fun things with this to kind of make it a real runner game. You could, you know, create little obstacles in the middle so that the player has to jump over them. Obviously, you can add a whole like incentive system of like collecting things. You know, maybe collecting different combinations of things. To, you know, make different kinds of effects. That would be fun. Provisioning or creating different mobs behind the player, so that like, okay, you know, there's just different incentives. Like if you got skeletons, then maybe you want to do something different. But yeah, this is pretty fun. You know, it kind of makes for a nice little fun mini game, kind of a chill kind of a mini game that you can just play. And you know, again, imagine there was obstacles here. You'd probably want to make the runway a little longer so that it's not immediately popping in front of you. But yeah. Anyway, let's see if there's any other questions that folks have. I'll probably leave it here for now. I'll go post the code for this, you know, a little bit after. See, this is the effect I think I was looking for, which is like a little bit of like a running underwater thing. That's what I always like to do when I build Minecraft Creative Worlds, is build like underwater glass block aquarium things. So this is really nice, actually. Getting a little bit of caves, a little bit of ocean. But yeah, if folks have any other questions, let me know. I'll put the code for this up It's basically just one giant TypeScript file. Maybe I'll just paste it into the YouTube comments, or paste the link to mctools.dev, where you can go see it from there. But yeah, this was just a very simple Friday builds, but on a Monday. I wasn't able to do it last Friday because my internet was cut out at home, but thanks for bearing with me. And yeah, if there's no other questions, then we'll probably call it there. I'll probably be looking to do these about every 2 weeks. Maybe not this week, maybe the next week. But yeah, thanks everyone for watching. And if you've got any other questions or comments, please leave them in the video. Please like and subscribe if you haven't already. And yeah, that was just a quick idea. If you've got other ideas for Friday builds, stuff you want me to build, I'll take a look at that as well. And with that, my name is Mike Amerlon. I'm a product manager on the creator team, and thanks everyone for watching. Thanks for joining in. See you soon.